So we're ready to begin practicing slope-intercept form. So for an equation to be in slope-intercept form, it would take a form like this, where you have y equal to mx plus b, where m is telling us the slope of the line and b is that y value of the y-intercept that we reviewed in the last video. So there's always actually going to be that letter y, that variable y, and that variable x in your equation. It's just m and b that will change. So let's do a little bit of practice of identifying equations that are or are not in slope-intercept form. So let's take a look first at this one. We have y equals 3x minus 7. Is this in slope-intercept form? So yes, we have a y equals 3x, so right away you could look at this and say 3 is the slope of this line, plus b. So we're subtracting here, but that's okay. If you think about it, we could rewrite this as 3x plus a negative 7. So in other words, this is just identifying that the value of b is negative 7. So yes, this equation is in slope-intercept form. What about 2x plus 2y equals 9? This is not in slope-intercept form. Notice that the x and the y are on the same side of the equation, and y has a coefficient of something other than 1. Okay, what about this one? We have x equals 2y plus 3. This is not in slope-intercept form. Notice that to be in slope-intercept form, you have to have y by itself on one side of the equation. This y has a coefficient attached, and it's not by itself. This is not in slope-intercept form. This one is almost in slope-intercept form. All we would have to do is get rid of this 4 coefficient. So as it stands, it's not in slope-intercept form. If I divided everything by 4, that would put it in slope-intercept form, but as it is, it's not quite there. Okay, what about this one? Y equals negative 6x plus 8. Yes, this is in slope-intercept form. So it's okay if your m value, if that value of m is negative, or if that value of b is negative, that's okay. So in this case, we have a negative 6, and that's alright, it's still in slope-intercept form because we have this y by itself on one side of the equation with no coefficient, and on the other side we have x being multiplied by some number and our constant. What about this one? Negative y equals 11x plus 3. Once again, we're not quite in slope-intercept form because we have this negative y. This one we actually do need to make sure that it's a positive y. So while it's okay if we have a negative m value, a negative x, a negative b, this y has to be positive. So I'm going to say that this is not in slope-intercept form. Not quite. And what about this guy? This one's a little different. Y equals x. This one actually is in slope-intercept form. And that's because we have this y that's by itself. It doesn't have a negative, it doesn't have any coefficient attached to it. X is on the other side of the equal sign. And there's no b, but that just means that the value of b is equal to 0, right? And you can see there's no coefficient. We didn't actually have an m written in here, but that just means that the value of m is 1, right? When we just have the letter x by itself, we know that it has an invisible coefficient of 1. So this one, y equals x, is in slope-intercept form. And one more quick example. It's okay if you have it kind of reversed. So if I had, for example, 2x plus 7 equals y, this is also in slope-intercept form, even though the y is on the right side instead of the left. The fact that the y is by itself with a coefficient of a positive 1, and then we have the x and its coefficient and the constant term on the other side of the equation, that's the important part. Because we know we could just very easily rewrite this way and it would be the same thing. So this one is also in slope-intercept form.